Namaskar and welcome to StudyIQ. I am your friend Rahul Saigaonkar. Let's continue our discussion of NCERT Science series. And in today's discussion of NCERT Science textbook for class 10, we are going to discuss chapter 12, that is electricity. Now, before this, we have already completed from chapter 1 to 5, where we have gained insights into the knowledge of chemistry from class 10. From chapter 6 to chapter 9, we have discussed some important concepts connected to biology. And recently, we started with the discussion of physics. We discussed chapter 10, light, reflection, refraction. Connected to this refraction itself, we discussed human eye and the colorful world. And today, we'll talk about this idea of electricity. We'll get some basic details, whatever are required for UPSC Civil Services preparation. All right, let's begin our interaction. Now, the concept of electricity is relatively new. I can say electricity as an idea, it is of the modern world. It's not of the medieval world. You do know during ancient times, during medieval times, there was no electricity. The concept of electricity has emerged during the modern times, since the time we are able to control, we are able to transmit, generate, control, and transmit electricity. So in this discussion, we'll understand what is electricity, or how do we define electricity. We define it through the concept of electric current. What is the meaning of electric current? What constitutes current? And how that electric current moves from one place to another place. We'll understand all these things, and from the perspective mostly of our day-to-day life itself. All right, let's begin. First things first, what is the meaning of electric current? When I say electricity and electric current are used, I would say, synonymously. Electric current is basically the movement of electric charge through a particular area. So electric current, it is expressed as the amount of charge that is flowing through a particular area in a unit time. Now we defined two terms. One is the term called as electric current, and another connected term, that is electric charge. Electric charge. So this electric charge means basically movement of electrons, and I'm telling you that electric current is the movement of this electric charge through a particular area in unit time. That's how we define electric current, and it is denoted by the term I. You must have seen, if you have any devices at your home, you must have seen there is some sort of rated current on it, and it differs from equipment to equipment. For some equipment, it might require milliamperes of electric current. For some, it might require a little higher current. For instance, this panel is connected to the board. The board is there, and that board itself, it has a connector of 16 amps. That means the connector can handle up to 16 amperes of electric current. All right. So I, basically electric current, it is defined as Q by T. Q means the amount of electric charge moving through one particular time. Now you will have a question. So what is this electric charge? Do I have any defining parameter for electric charge? Yes. Electric charge, it is expressed to a unit called as coulomb. Electric charge is expressed in coulombs. It is measured in coulombs, and its measure is basically the charge that is contained in nearly 6 into 10 to the power of 18 electrons. It makes 1 coulomb. It makes 1 coulomb. So 1 coulomb, it's equal to 6 into 10 to the power of 18 electrons moving. And when they pass one particular area in a unit time, that makes electric current of 1 ampere. Now electric current, it is denoted or expressed in the unit called as ampere, and 1 ampere power, that would be equal to 1 coulomb of charge. That means 1 coulomb is equal to the charge that is carried by 6 into 10 to the power of 18 electrons per second, per unit time, per second. That is the meaning of 1 ampere. So 1 ampere is very high current. Okay, it's a very high current. In fact, many of your equipments, they use microampere or milliamperes of current. There are some which are high end equipments, or which require more power. They use higher ampere electric current. All right, so that's why you must have seen that there are many equipments which are mentioned or expressed in terms of milliamperes or microampere as well. And when you connect in a circuit, if I want to measure the current, I connect an ammeter to it. Ammeter is denoted by this A. All right, this is a simple current where the power is flowing here. And please remember, when I say electric charge in a conventional way, you need to remember something, that in a conventional way, the movement of electrons happens in one direction, and conventionally we say electric current is moving in the other direction, because conventionally we say current is the movement of positive charges. All right, please remember this particular point, very important from MCQ perspective. So when I connect a circuit, current is moving and it is lighting this particular bulb. If I have to measure it, I connected ammeter to it. Please remember, ammeter should always be connected in series. It cannot be connected in parallel, because say imagine if I connect an ammeter parallelly to this particular bulb, hypothetically if I connect ammeter here, meaning current would pass through this bulb, current would pass through ammeter through a separate line or a separate segment. All right. Right. So what did we understand? We understood the idea of electric current. Electric current means movement of electric charge. Electric charge is measured in coulombs. How much amount of coulomb per unit time is moving, that is defined as current. All right. Now, this current has to move from one place to another place, correct? Current has to move from one place to another place, from say point A to point B. Now, how does this current move? Why does this current move at all? Now, to understand electric current, let's study it in an analogous way with other currents. Now, you know air currents. Air current means basically wind or movement of air. We also know water currents. That's why there are two diagrams. You must be getting confused that, sir, we are discussing electric current and you have put the diagram which talks about winds. Now, this is the example of winds. These are the winds itself in our atmospheric circulation wind system. These blue ones are the westerlies. You have yellow trade winds in the northern and southern direction. And this is the ocean currents that you have, right? You know, in ocean currents you have many. There is north equatorial current, there is south equatorial current, right? There is Venezuela current, there is Gulf Stream. There are many ocean currents. Now, do you know why air current or current of air moves or water current moves? Now we have understood that from our basic I would say physics 101, whatever we have understood from 6, 7, 8, 9. We know, sir, air moves from a location of high pressure to a location of low pressure, correct? Or wind is nothing but a movement of air from one position to another position, high pressure to low pressure. Now same thing with water also. You do know water, it needs some sort of gradient, isn't it? It needs some sort of gradient. Say it can be gravity. If I simply have a horizontal pipe and I put water into it, it will not move. There has to be some gradient. It may be because of gravity. Or it may be because of some other characteristics. For instance, the ocean currents are because of stratification of ocean water. The ocean water is stratified based on temperature, based on density. We do know that warm waters, they are above, and below these warm waters you have dense and cold waters, and that's why you see circulation mixing. So we understand that for any current, be it water current or air current, there has to be some sort of gradient, isn't it? There has to be some sort of difference, meaning from point A I have to move it to point B. That means there has to be some difference between these 2 points, correct? Now, for electric current, I understand two things. First, if I have to transfer current from point A to point B, first thing is they have to be connected. Now they have to be connected. From in the modern times, we have understood they have to be connected through a conductor. I just wrote the spelling of conductor wrong. Okay, it happens sometimes. All right. So I have to connect them through a conductor. What else is needed? There has to be some sort of a difference between these two, very similar to how gradient is needed for water and air. The flow of charges through this conductor, it will occur only when there is potential difference along that conductor. That means there has to be different potential here. And what is that potential? It is called as electric potential. For air, it is from high pressure to low pressure. For water, some gradient, okay, it may be gravity or any other parameters that we saw. And for electric current, there has to be difference between the potentials at point A and point B. Now comes the question, sir, what is this potential? I want to understand what is this potential. I understood that there has to be a difference. That means electric potential difference has to be there between these 2 points. But first of all, how do I define that electric potential? Now, electric potential is defined as the work done per unit charge to bring a single charge from infinity into a point in the electric field. Meaning, see, how much amount of work is done. Imagine that I have electric field here. I have electric field and the electric field lines are emanating outside. Yes. Now, what is this potential, electric potential? There is one particular charge here. Now I have to bring this charge into the electric field at one particular point. The amount of work done that is needed to bring this charge into one electric field, it is called as potential. And what is the potential difference? Potential difference means if I have to transfer this particular charge from one point to another point inside the electric field. That's the basic difference. It's a little technical, but if you keep this in mind, that potential, electric potential means it is the work needed to bring unit charge from a point at infinity into the electric field, into one point in the electric field. And the same potential difference or the electrical potential difference that we talk about, it is the difference between or work done to bring a point in that field from point A to point B. And how do we calculate it? Remember, a potential difference between 2 points in an electric field, they depend on work done and the charge, whatever you're moving. Work done. Now work done means work is measured in joule. You do know unit of work is joule, right? And unit of charge is coulomb. So one voltage potential or potential difference, they are calculated as work done per charge, meaning joule by coulomb. All right. Now the question is, what kind of difference is needed? I told you, for movement I always need I always see that the charges will move from high potential towards low potential. From high potential towards low potential. All right. Meaning, if I have to transfer this charge, there is high potential needed here, there is low potential needed here. Then some electric current will move. Some electric current will move. All right. Right. What is the difference or what is the relation between this voltage and current? We'll understand in some time when we talk about the Ohm's law. But right now, what we understood, there is an electric current, which is nothing but movement of charge. That movement of charge, it depends on the potential difference between 2 points. All right. Now, the next idea is, when I connect something in series, I have to measure two things. That means through the ammeter, I measure the electric current, and through the voltmeter, I measure the voltage, whatever is there. All right. Now, in a circuit, when we draw, there are some connotations which we need to know. Sometimes questions might arise on this. I would say there is very low probability of question coming based on circuits in UPSC civil services examination, but in NEET, JEE, you will find these questions a lot, right? An electric cell is denoted like this. You draw a longer vertical line and a shorter vertical line and just connect it. This would become the positive terminal, this would become the negative terminal, and you put it in the combination again. Please remember, you cannot combine. Now I cannot do this, you do understand, because they will neutralize each other. That's why if I have to connect next battery, again it would be positive and negative in this direction. This is in series. So similarly, this is the definition of a plug or a switch. This is a simple wire joint, a T joint. This is wire passing without joining in a circuit. They are not joined. This is electric bulb, or many a times it is also denoted or written as load in many circuits. This is the connotation for a resistor. What is a resistor? We'll talk about it in some time. This is ammeter. A is ammeter, V is voltmeter. These are the connotations that we use in electric circuits. Now, question comes, sir, what is the relationship between electric current and voltage? Because of course, by now I have understood that current will pass, and that current, it depends on voltage or the difference in voltage, the potential difference that we call. So this relationship was given by Ohm. by the discoverer Ohm. That's why it's called Ohm's law. Now, Ohm's law, it basically gives the relationship between your voltage and your current. And it can be best described through this particular diagram. Can be best described through this particular diagram. Now, you see, the potential difference or the voltage, it is trying to push the current. You do understand, because of the potential difference, because of the voltage, the current is trying to move through the conductor, and this current is resisted by this ohm. Ohm is a unit of resistance. So this is Ohm's law, where voltage, current, and the resistance relationship is given. Voltage is directly proportional to the amount of current that passes in a circuit. All right. So remember, voltage is directly proportional to the amount of current, that is the potential difference. It decides how much amount of charge will move in unit time or per unit time. Voltage is directly proportional to current. If you remove this proportionality signal or proportionality symbol, pardon me, you get the constant called resistance. And if you draw a graph, you will see that the resistance graph would come something like this. Any circuit or any device which follows a relationship between voltage and current in such a way that resistance graph is something like this, these devices are called ohmic devices. These devices are called ohmic devices. That means they follow Ohm's law. All right. Right. So this is Ohm's law. Now, next thing, what is this idea of resistance? Because using this concept of electricity, I have understood that there is some sort of a constant called resistance. Resistance is that constant which establishes a relationship between voltage and current. Now, what does this resistance depend upon? Because it's very important for me, because I have understood to move a charge from one point to another point, I do need a conductor which is able to transfer those charges. And resistance is a property connected to that conductor. All right. Now, what does resistance depend upon? Resistance, it basically depends upon the length of the conductor, length of the material. It depends on the area of the material, and it also depends on a constant which is connected to that material. It is denoted by rho. So resistance is equal to rho length by area. So resistance depends on the length of the material. Please remember, longer the material, greater will be its resistance, because it is directly proportional. The second thing is area. Area, it is inversely proportional. That means larger the area, lesser would be the resistance. It also depends on temperature. Although it is not there in the formula, but the resistivity, it ultimately depends on the temperature. So resistance, it depends on temperature of the material. Higher the temperature, higher the resistance. Very important, remember this. Higher temperature, higher resistance. That's why you talk about superconductivity. Superconductivity means very low resistance. At what temperature do you achieve superconductivity? Very low temperature. That's why you see we talk about quantum computers. Quantum computers, they work on the concept of superconductivity only. That's why the quantum computer itself, it needs very low temperatures for working. All right. That way you can remember. Again, it also depends on the material. Material means this constant which we define it as rho, or resistivity of the material. It also depends on that. Different materials have different resistivity. For instance, from NCERT, if you look at these conductors, they have very low resistivity. If they have low resistivity, low resistance, they allow current to pass very easily. You can see silver, copper. Copper is something that we use for connection, for making wires. Aluminum also. There are many other metals that we can use. You can see the resistivity is very low. It is of the order of 10 to the power of -8. But if you look at insulators, their resistivity is extremely high, of the order of 10 to the power of 10, 10 to the power of 12, 13, 14. That means they do not allow current to pass through them at all. They do not allow charges to pass through them at all. Again, there is no need to mug up these numbers, but I want you to understand that the resistivity of conductors is very low, resistivity of insulators is very high. That means the resistance depends on that resistivity. Clear? Right. So what all we have established? We have established the meaning of electric current. Electric current is the movement of charges. That movement of charges happens because of voltage potential difference. And we have understood the relationship also between them. Now, when we talk about connections, how do we connect any equipment? Say when I say any equipment, that equipment has some resistance, right? So any equipment or any resistor, how do we connect? We can connect them either in series or we can also connect them in parallel. Whenever we connect multiple equipment or multiple resistors in series, remember the ultimate resistance or the complete resistance, it is nothing but the sum of all the resistances. If resistors are connected in series, the final resistance or total resistance is equal to R1 plus R2 plus R3. But if they are connected in parallel, then their resistances equation, the total resistance will be 1 by R1 plus 1 by R2 plus 1 by R3. That is equal to 1 by total resistance. Now, why does this happen? Please try to understand that whenever I connect things in series, you will see that they will have same current passing through all the three. They will have same amount of current which is passing through all the three. Correct? But whenever you have something in parallel, you see that the current, it divides. Now, depending on these resistances, I told you more current will flow where? More amount of current will flow where the resistance is least. High amount of or less amount of current will flow where resistance is higher. That's why across these three, the current will be different. But in all these three, current will be same. Current passing would be same. That's why we get these equations. Now, why did I discuss this? Because see, in many of our household equipments, you will see that we seldom connect things in series. Right? It doesn't mean we do not connect in series, but many a times we connect things parallelly to our electric lines. Why does this happen? Because see, you have connected your fridge to a parallel line, you have connected your AC to a parallel line, your lights to a parallel line. Why? Because if same amount of current flows through all the equipment, some equipment work on milliamperes, some equipment microamperes, some work on multiple amperes. So if the rated current goes high, then the equipment will burn off. Clear? That's why we see that series connections are specific. In general, in your house also, you will see more and more of parallel circuits or parallel connection, because we want individual amount of current to reach according to its rating. Clear? Right. Now, apart from this, we also have a concept of electric power. You have a doubt, sir, how do I get my electricity bill? Is it based on the amount of current or is it based on the voltage that I receive? You do understand voltage that we receive at our house is somewhere around 220 volts, 220 to 30 volt. And I told you it moves from high voltage to low voltage, of course. And that is why, if you understand how does electricity pass, just a little bit of deviation from our discussion, you do understand how electricity comes. Electricity, first of all, is generated. Now, where do you generate it? Electricity is generated at the generating station. It may be a hydroelectric power station, it may be a nuclear power station, it may be coal-based power station, whatever station it is, electricity is generated. And do you know how, at what voltage electricity is generated? Generally, it is somewhere around 11 kilovolts. Electricity is generated at 11 kilovolts. That's the potential. So from here, it is going to reach to your home. And your home, what at how much voltage does it reach? We have a rated voltage of somewhere around 220 volts, 220 to 30 volts as per requirement. That's a single phase. For a double phase, it would be 440 volts. Especially for industries or for heavy equipment, we use 440 volts because they need more current, right? Now, you need to understand something happens in between. Now, this middle part, it is called as transmission. This is called a transmission. So you need to understand, from generating station to the transmission station, it ultimately reaches. Now, when you talk about transmission, please remember, transmission losses would appear because we understood concept of resistance. Now, because of this resistance, there would be many losses. There would be many power losses. Now, how do you define this power? Now, power is basically voltage into the current. Now, if I use Ohm's law to this, I get power is equal to I square R, because voltage is something which I would keep it fixed, but I can control the amount of power that is moving through the transmission line, because current, and current ultimately depends on power. What I mean is voltage, I generate power at say 11 kilovolts. 11 kilovolts is there. Now I have to transmit from one place to another place. I have to reduce the transmission power losses. Now transmission power losses, they depend on current and resistance. All right, because the voltage at which I'm generating, I have kept it as 11 kilovolts. So what do? I try to ensure that less amount of current passes through it. If less amount of current passes through it, then I ensure that the power losses would be minimum. That's why what these substations do, what the transmission stations do is, when it is generated, they will step up the voltage. They will use step up transformers. And this particular 11 kilovolt, it's stepped up further so that the losses are less. And here, after it reaches the substation where it is being supplied, then it would be stepped down. It would be stepped down transformers. Transformers are one which reduce that voltage. It would be stepped down, and ultimately at your home, 220 kilovolt would be provided. All right. Why? To reduce the power losses, of course. Power depends on I square R. This is called power factor also, I square R. Now you still have a question. Sir, power, how do I get a bill? Does it depend on voltage or current? No, it depends on how much power you use. And how much power? See, the unit of power would be watt, because it depends on voltage and ampere. So 1 watt is equal to 1 volt ampere. But many a times for our power consumption, what the stations that they do is they use another unit or another factor for power, that is kilowatt hour, meaning how much electricity or how much electric charge you are using per time. That way power is calculated. For example 1 kilowatt hour, it leads to 1 unit at your home. You have a meter earlier that used to revolve. Right now they have digital meters. That means once you consume 1 kilowatt hour, your reading would go +1. And in Karnataka right now, 1 unit is costing 7 rupees. So for 1 kilowatt hour usage, you will pay 7 rupees to the Gescoms or to the whatever distribution companies they are supplying power to you or electricity to you, right? So 1 kilowatt hour basically means, in simple plain language, you switch on 10 100-watt bulbs that you have at your home and you run them for 1 hour, 60 minutes. Then you will consume 1 kilowatt hour. That means 1 unit would be passed. So this is your electricity bill or electricity unit that we talk about at our home. All right. But in general, power is equal to V into I. Power is also equal to I square R factor. Power depends on the amount of current that is passed, amount of current, square of the current, and the resistance. You do understand, I cannot change or play around with this. Correct? I cannot play around with resistance because I use only one kind of wire. You have aluminum wires for transmission. I cannot change that material. So what do I play around with? I play around with the amount of current that passes through it. So I reduce the amount of current by stepping up the voltage. So during transmission, the losses are less. But I again step it down so that more and more amount of current, whatever is required, it reaches your home. Clear? Right. Now, apart from this, the electric current, it also has heating effect. Now, this we have discussed before also. You must have observed this as well, right? You must have seen. You have an incandescent bulb at your home or any kind of bulb at your home. Electric current passes through it. It is going to give you light. Now, when I switch this on, it is off right now. I switch on the circuit. I switch on the main circuit. Now, this is giving me light. Yes. But along with light, it is also giving me heat. Correct? It also gives me heat. So electric current, when it passes through a conductor, it has heating effect. And how much heat, it depends on the power factor, that is I square R again. I square R again, meaning how much heat is to be generated, that depends on the amount of current and the material that I use. Now, using this phenomena, we see because of this heating effect of current, we have created so many things, so many articles. Now, for example, for my light, a light is there. For my light, I do not want heat to be generated more and more. I want light. I do not want heat. So what do I use? I use very low resistance materials. But imagine I want electric current to give me heat. Why? Maybe I want to create something. So our day-to-day activities, we use fuse. Now I create a fuse through which there is a very small thin wire, and if it gets heated up, it will melt off. It will cut down the circuit itself. There are many appliances like the electric heater where I create some sort of material which has very high resistance, and when I pass electric current through it, it heats up. You must have seen your room heater, you must have seen your electric iron, etc. I use heating effect of current and I use that as an appliance. And this heating effect, again, it depends on what, as I told you, P is equal to V into I, which also makes it I square R. This is called as power factor. Now, the energy supplied to circuit, this amount of power into time, that will give you whatever heat losses are coming. So heat basically is V into I into the amount of time. So heat that is generated from any equipment, it is equal to I square R into the amount of time through which the current is being sent. So if I want heating effect, what do I want? I want more resistance, I want more current, and I want to send it through more time. So what do I get? I get more and more amount of heat. That's why go home and check your appliances today. Check your appliances, your electric heater, your electric room, your electric iron, how much current it takes. It'll take higher amount of current. Higher amount of power is needed. Your electricity bill would also be very high, right? I hope I have given you a good insight into this. Do not go into the numerical part. Again, do not mug up the formulas as well. These formulas are also not needed for us, but we need a general idea about how exactly electric current passes, or what is this concept of electricity. All right, that is it in today's discussion. Before I move out, I have a notice for all of you. You do know that we are launching another P2I session. It is starting from 11th August 2023 at 8 a.m. So do not miss out this train, because it would be one of the last batches for P2I for your preparation for 2024. Do not delay it. Do it now. Just go to our website www.studyiq.com. And also, if you have liked this video, you can always follow me on this particular ID. If you have any queries about P2I as well or anything, you can always reach out to me on this particular ID. DM me on Instagram. I do respond on Saturdays and Sundays. Thank you for watching this. Jai Hind.